Yeah, I'm Jesse Jiryu Davis. I work for MongoDB. I'm a senior staff researcher at the MongoDB Distributed Systems research team. Distributed databases are just about the most complex kind of software and the most mission critical that we develop in industry today. We cannot lose customer data. We cannot violate our consistency guarantees. We must be resilient to any conceivable fault, from a disk failure to lost network messages to clock skew to a hostile attack. The database is at the core of everybody's business, and it's probably the most complex piece of software that any business is running. For us to have to report that there has been some sort of critical bug, it's the most serious kind of critical advisory that we have to publish. And so our whole test infrastructure and strategy is focused on catching those bugs in software before it's released to the public. To prevent releasing software with bugs to the public, MongoDB, our design process includes just a lot of thinking up front, modeling in formal languages like TLA+, writing very detailed design documents and discussing them with lots of teams. We obviously code review and test the heck out of every commit that we make to our code. This includes thousands, sometimes tens of thousands of hours of concurrency stress tests in multiple configurations. What we've found with Antithesis is that it can explore extremely rare sequences of faults and bring our software into extremely unusual states that reveal bugs that thousands of hours of conventional testing have not revealed, whereas within 24 hours or less of Antithesis testing time, those bugs are reliably reproduced. The big advantage there is that not only do we find bugs, but if we think that we have fixed it and we test with Antithesis again and Antithesis does not find it, then we have confidence that we actually have fixed it, which our previous test strategies didn't give us. Before we started using Antithesis, our test strategy for rare bugs is just to run stress tests over and over and over again, hoping that those rare bugs might someday manifest. In the case of extremely rare bugs, that might take years with only 1 or 2 reproductions of the bug. Obviously, this makes it hard to diagnose the bug or to tell if we've fixed it. Antithesis gives us more confidence than we've had before that we will see very rare bugs soon after we've introduced them, and that if we fix them, we will know that we have actually fixed them. And it can do this much more efficiently than just randomized traditional stress testing. When we first tried Antithesis, we had a set of 5 very rare bugs, and one of them we thought was about 8 years old, but we only had 1 example of it appearing in our standard testing system. And so that bug had managed to evade millions of test runs without being reproduced. We submitted our prototype tests to Antithesis to try it out, and within 24 hours, that bug was instantly reproduced and continued to be. And so for the first time, we actually were motivated to attempt a fix for this bug because we now finally knew that we could test whether we had fixed it. I think Antithesis has the potential to really transform how we test systems. Already, I think it has the ability to save businesses a lot of money. So it has the potential today, I think, to save millions in cloud costs for most businesses. In the future, I think that it's going to, by exploring the entire state space of a program, make possible things that we haven't been able to really even contemplate today. I think today we've got this trade-off in all engineering between quality and velocity. The more you care about quality, you tend to just write more and more and more tests. And then the moment that you change something with your software, you may have to update half of your test suite to match the new correct behavior. And so you become either deterred from adding new features to your software because it's going to break your old tests, or deterred from writing tests because it will make new feature development slower. So often in our industry, we're just sprinting to the next release, and we're trying to get another feature out, and quality is negotiable. I think we should change our minds about that. I also think that for a given quality level, many companies could achieve that with Antithesis with less money, because Antithesis doesn't waste time rerunning tests that follow the same code paths over and over again. For companies evaluating Antithesis, one question might be, how much money are you wasting today running non-deterministic and flaky tests that are failing to explore some scenarios while rerunning the same scenarios over and over and over again? How much money are you wasting that versus how much you would spend using Antithesis to systematically explore your software's behavior today? That might be a good first question, and then how much can Antithesis improve quality by finding unknown bugs might be the next question after that.